Hi, this is Miss Dietrich, and today we're doing 8th grade Mod 4, Lesson 16, the computation of slope of a non-vertical line. Remember, a vertical line is just straight up and down, and you can't find the slope of that. Students use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in a coordinate plane. Students use the slope formula to compute the slope of a non-vertical line. So the slope formula is the change in y divided by the change of x. And when you change things, what's the difference between them? So you're subtracting. We'll learn to start writing this as delta y over delta x. Determine the slope of the line with the following graph. So I need to find where this line right here intersects the grid lines nicely. So I can see right here, and that point is 3, 4, and right here, and that point is 2, 1. Remember, when you write the points, it's how much you go over and then up. Let's label these. This is my x and y, x and y. I'm going to label the first set I picked is x1, y1, and the second set x2, y2. So using the formula, I want to subtract the y values and then subtract the x values and then divide the two. So slope equals delta y, the change in y over the change in x. That's very important. So we have y2 minus y1 over x2 minus x1. I need you to write that. I'm going to plug my points in. 2 is 4 minus my y1, which is 1, over my x2, which is 3, minus my x1, which is 2. So that gives me 3 over 1. So my m equals 3 over 1 equals 3, which means that we go up 3 and to the right 1. So going up 3 to the right 1 gives us this little triangle. So we have 3 units and 1. So that's how we get our slope, y over x. Determine the slope of the line with the following graph. So let's pick 2 nice points. There's a point and there's a point. So the first point is I go over 0, up 1, and the second point is going over 1 up to 3. So I went from here to there. So my y is 2, my x is 1. Let's take a look. If we use the slope formula, we started with this, so this could be x1, y1, x2, y2. So our formula, m equals y2 minus y1 divided by x2 minus x1. That's our delta y over our delta x. We're going to do 3 minus 1 over 1 minus 0. 3 minus 1 is 2. 1 minus 0 is 1. So our slope is 2. So if m equals 2, which is the same thing as 2 over 1, which will be helpful when we graph. So that means it goes up 2 to the right 1. It's your y over your x. Example 3. What is different about this line compared to the last 2 examples? Well, it looks like a line. It's going up, so it's positive. Those are what the other 2 were. This one looks much shallower of a slope, so not as large of a slope. Let's take a look at the slope. Let's figure it out. So in this example, we have 2, 1, and 5, 3 are my points. So to go from x1, y1 to x2, y2, I'm going to have to go up 2 to the right 3. So that means my slope, which is y over x, is 2 over 3. Let's make sure we have that right by using the slope formula. So my slope formula is y2 minus y1 over x2 minus x1. So I'll have 3 minus 1 over 5 minus 2. 3 minus 1 is 2, 5 minus 2 is 3. So my fraction would be a decimal and not a whole number. So this is a much shallower slope than the other ones. The other ones were much steeper. So this means that my m is 2 over 3, which means up 2 to the right 3. Determine the slope of the line with the following graph. Select any 2 points on the line and label them P and R. I'm not gonna pick a point right here on the line. I got to pick a point I can determine numbers. Let's do those 2 points. So it's -4, -3, and this one is -1, 3. So now we're using negative numbers. So we'll label this one P and this one R. Since P was first, we're going to do x1, y1, and R will be x2, y2. So P is -4, -3, and R is -1, 3. Wants us to find the slope using as many different points as you can. Identify your points and show your work below. So we're going to do m equals y2 minus y1 over x2 minus x1. So identify the coordinate points of P and R. So we're just going to label these. So -4, -3 for P. This is going to be our x1, our y1. And then for R, -1, 3, this is our x2, y2. So let's make sure we plug it into the equation correctly. So my y2 is 3 minus -3. Or x2 is -1, and my x1 is -4. So we have 3 minus -3 over -1 minus -4. Using the parentheses will help you determine that you don't have too many or too few minus negative signs. You'll see that this is minus sign with the problem, and you're putting in a negative number. So 3 minus -3 is the same thing as 3 plus 3, so that's 6. So that means 1, 2, 3, 4, 5, 6. We went up 6. And then -1 minus -4 is the same thing as -1 plus 4, which is 3. So 6 over 3 is 2 over 1, which is 2. And that means we went right 3. So let's pick another point. Let's pick -3, -1, and -2, 1. So this is our x1, our y1, our x2, our y2. So m equals y2 minus y1 over x2 minus x1. Yes, you have to write all this. So now we have our x2 is 1 minus, let's plug in our numbers over our equation to make sure we don't get them wrong. So our y2 is 1, then we have minus y1, which is -1. My x2 is -2 minus the -3. I do a lot fewer mistakes when I do it like that. So I have 1 minus -1 is the same thing as 1 plus 1 over -2 minus -3 is the same thing as -2 plus 3. So this is 2 over 1, which is 2. And it happens to have the same slope. So the same slope.